Hi, everybody. Today we are going to look at the biodiesel structures. I wanted to do this first today because it gives a good way of first transitioning and from our previous topic, and a good way to practice drawing these structures with some more complicated molecules. And then also, of course, we're starting the biodiesel project this week, so this will be a good intro into what we're going to be doing in the lab. As always, I am in Z341. If you want to come by, just knock on the door here and I'll let you in. Right now there's nobody, so I'm going to just be talking to the internet. If you have questions from the internet, just put them in the chat and YouTube, or just send a message on Teams and I will respond. All right. So let's take a look at these structures. So last time we talked a little bit about how to draw these line structures of molecules. So just to kind of quickly review that, definitely go back and watch that video, practice those practice problems. We're going to do that a little bit in lab tomorrow as well. But remember that we draw these carbon chains like this. 1, 2, 3, 4, 5, 6 carbons in this chain, and then we assume enough hydrogen atoms so that each carbon has 4 bonds. So this first one would have 3 hydrogens that aren't shown. Whoops. Sorry, got my calculator somehow. The second one would have 2, and so on. So go back if you're not sure about that, because we're going to be using these structures pretty much exclusively with the biodiesel because these molecules are so large. All right, so let's start talking a little bit about what we're doing here with biodiesel. So first of all, what is this? Biodiesel is diesel fuel from plants. Traditional or regular diesel fuel, non-biodiesel diesel fuel, comes from oil. So, we get oil out of the ground where we get gasoline from, and part of that, so the crude oil has all these different things in it, and it gets distilled, separated into its different components, and diesel is one of those components. And diesel is a special kind of fuel. As you might know, you can't put diesel fuel in a standard gasoline engine. You can't use gasoline in a diesel engine. Diesel engines work a little bit differently. They don't have spark plugs. They act on pressure. So when the piston compresses the fuel in the cylinder, it causes it to combust, and then that produces the power for the engine. Diesel fuel is used in a lot of heavy equipment, semi trucks, and large, towing trucks and things like that. It tends to have more torque, and there are some other issues with it. It's fallen out of favor as a fuel for regular cars. It was never really that popular in the U.S. to begin with, but even though it can be more efficient in terms of like gas mileage than gasoline, it has other pollutants that come out of it that gasoline doesn't. So while carbon dioxide wise and climate change wise, it might be a little bit better, there are all these other pollutants that diesel fuel produces. Now, modern diesel engines, you have to put the special fluid in there to like clean up the emissions of the diesel. So it's really only used in heavy equipment, but that still accounts for a lot of fuel use in this country and in the world. So biodiesel is a way to get this type of fuel directly from plants. So you can grow the plant, you can get this stuff, and I'm being vague because I'm going to show you how to do that in a second. And then you can burn the fuel, so it's effectively carbon neutral, more or less, because the plant is taking in the carbon dioxide to grow, and then you're burning it and releasing that carbon dioxide back into the atmosphere. So the way that we do that is it actually comes from the oil. So you can make diesel fuel from most plant-based oils. We're going to use vegetable oil or canola oil. And so what you do, you can actually You actually can use just pure oil, like cooking oil, in a diesel engine, but it's too viscous, it's too thick. So if the engine is warmed up first, you can actually just put regular oil in there, but you have to have separate fuel lines and stuff so you can switch over once it's warm and then switch back as it's cooling down. So by doing this chemical process that we're going to do in lab tomorrow, the fuel can just be used directly in a diesel engine. And in fact, if you go to any regular gas station and you look at the diesel fuel pump, chances are it will say that it is some percent biodiesel. And these days, it's usually a pretty high percentage biodiesel. So a lot of diesel fuel now is being replaced by biodiesel rather than the diesel that comes out of the ground. All right, so let's look at chemically what we're talking about here. So in order to see kind of what's going on, we first need to know something about the structure of oils. So oils are, this is not crude oil from the ground, this is like plant-based oils. Oils belong to the macronutrient category lipids, which we'll talk a little bit more about in the next module. So that's any kind of non-polar type molecules. Again, we're going to get into that more actually this module, but probably next week, maybe a little bit tomorrow. So these would be fats, oils, waxes, and then other types of molecules, a lot of hormones and things like that fall in this category as well. They are predominantly what we call triglycerides. Oils are. A triglyceride is 3 fatty acids condensed with the molecule glycerol or glycerin. All right, so fatty acids are these, talk about those next. Fatty acids are molecules that have this type of chemical functionality on one side. So a carbon double bond with oxygen, and then OH, that's called a carboxylic acid, and then a bunch of carbon atoms behind. I'm just going to sort of trail off there. I didn't mean to have a specific amount, but just a bunch of carbon atoms with hydrogen. So you imagine that like a really long line structure, and different fatty acids have different tails, let's say. Let's call that the tail. Different fatty acids have different tails. Some have 12 carbons, 14, 20, 24, depending on the molecule. Some have double bonds, some have all single bonds. There are lots of different fatty acids. So that's what a fatty acid looks like. So when these things condense with the glycerol molecule, you get a triglyceride. So glycerol looks like this. It has it's a small molecule with just 3 carbons, and each carbon has an OH, which is called an alcohol functional group, attached. So when these things come together, 3 fatty acids and glycerol, you get this molecule called a triglyceride. And I'm going to draw one such thing. As you can imagine, with these, they get pretty big. So actually, I'm going to give myself a little bit more space here. So here's my kind of tail of the, or backbone of the glycerol molecule with these O's coming off of it. And then coming off of those O's are like the tail part of each fatty acid. So we're going to have this C double bond O and then this long tail. Long tail, all right? And that's a triglyceride. Now, if we were to draw this in a little bit more of a all line structure fashion where we want to actually look at some of the geometries, we end up with something like this. So the glycerol ends up being shaped sort of like that. It's not quite right. Sort of like this. Where one of those, you could see it, like these things kind of start to interfere with each other, and so one kind of flips over to the other side. So you end up with this kind of a thing going on. And here's the long tail here, and here's the long tail and a long tail there. So almost like a fork type configuration. And that's what a triglyceride would look like. All right. So that is the oil. That's what we're going to express as the oil. Now, oils are natural products. You know, the vegetable oil comes from a plant, so it's not one pure type of molecule, which is why I'm just drawing squiggly lines and not like specific numbers of carbon atoms. We will actually see by the end of this project which molecules are um, in our final product using some analytical techniques, specifically GCMS, which we'll talk about later when we get to that. We'll be able to see that, but for now we're just going to say, okay, it's this like fork-like thingy. So what we're doing tomorrow in lab is we're going to take this molecule. It's literally just a bottle of vegetable oil like you would get at the store, which has molecules like this in it. That's what makes it up. And we're going to react that with methanol, which is the formula CH3OH, and then also NaOH, which is sodium hydroxide. All right. And reacting this and kind of cooking it up, we're going to heat it for like an hour, cook this thing up. And what that's going to do is it's going to break the fatty acids off of the glycerol. So it's going to kind of like split this thing up over here. And then it's going to return glycerol back to its original configuration with the H's that we drew up here. So like this over here. And instead of ending up with fatty acids, we're going to get similar molecules, but this methanol is going to sort of cap off the end. So let me draw what that looks like. So those three things are going to be broken apart so that we get three molecules that sort of start like this and have this long tail thing of carbon and hydrogen. And then the end, instead of being OH, is going to be CH3O. And we're going to make three of those from the three things that disconnected, the three fatty acids that disconnected. And then we're going to also make glycerol, this 3-carbon molecule with 3 OHs as a byproduct. And then with any chemical reaction, there's other types of things going on. Water's being formed. There's some byproducts. We're going to use an excess of methanol and sodium hydroxide, meaning more than we exactly need by measurement, because the reaction just works better that way. So there's going to be some leftover waste at the end. And so you'll see at the end there will be the product portion and the waste portion. So just focusing on the product part for right now, right here, this is biodiesel. And the chemical name here, well, I mean, these molecules would have specific long names that we will actually see later when we do the analysis. But in general, these types of molecules are called fatty acid methyl esters, or methane. And the reason this works well as a fuel, if we just used the fatty acids that still had the OH on the end, so if we left methanol out of this reaction, we only use the sodium hydroxide, we would have made basically soap, is what that is. And so what that would do is, because of the highly polar end, and some of the activity this week is about polar versus non-polar molecules, so hopefully that will make more sense once you've worked through that stuff. That, because of the polarity on the end there, it would make this molecule actually more like a solid, like a soap, and not able to work really as a fuel. When we cap it with the CH3, with the methanol, then it becomes something that we can use as diesel fuel. And so it will actually work that way. Now, to test this stuff, in a couple weeks, I don't remember exactly where it is on the schedule, but the lab day that says biodiesel analysis, we're going to take the stuff and we're going to test its heat of combustion, meaning how much energy does it actually have in it, and we'll be able to compare that to some other fuels. So this is the basics of the structure here. If these structural diagrams didn't make any sense to you, please go back and keep working on the stuff from last module, the drawing the line structures, because this is how we're going to talk about these things from now on. So you'll want to be more comfortable with these structures. We'll talk about safety in lab tomorrow, but make sure your lab notebook is ready and that you've got the procedure either printed out or copied into your lab notebook so that you can follow it tomorrow. There's really not any sort of like creative stuff in lab tomorrow where you have to like figure something out. You're just following a procedure to try to make this stuff. And so the creative and interesting part will come later once we actually have the stuff. All right. Well, let me know if you have any questions or if that is not clear. And tomorrow we'll do this in lab. We'll hopefully have a little bit of time when we're not actually working in lab to work on some of these concepts as well. And then we'll have another one of these live classes directly afterwards. So see you tomorrow.